Okay, so this section is on graphing rational functions. So this is a little tricky, but we'll go through it hopefully slowly and step by step so you can get some of the concepts. Okay, we're going to look at the reciprocal function. So let me get some graph paper here. And the reciprocal function looks something like this in the first quadrant and something like this in the second or in the third quadrant. And we want to talk about what's happening with the graph. We want to look at where the limits are, where it's approaching. I probably shouldn't use the word limits. But this is the reciprocal function. So f of x equals 1 over x. The reciprocal function is an example of a rational function. We have other rational functions, but this is an example. Let's start out with some of the things we've talked about, I think, in the past. There is a horizontal asymptote here. Okay, so this green little dotted line, I don't know if you can see it, that's a horizontal asymptote. The graph is not going to touch that line in this case, but it's approaching it. Now, with horizontal asymptotes, those are a little different, but we'll get to them. Anyway, it also has a vertical asymptote. So right here on the y-axis, this would be called a vertical asymptote. Our functions don't cross vertical asymptotes, okay? So just remember that. But now what we want to talk about is the symbols, the arrow notation to describe the behavior. So as x is approaching, we'll do the hard one first. As x is approaching 0, okay, so you're saying x is getting closer to 0. What does f of x do for this function? This is what we're saying. And the thing is, it does different things. Like in this case, it's going, if I'm going toward, toward in 0 here, it's going toward infinity. But if I'm going from this direction toward 0, then it's going toward negative infinity. So it makes a difference which direction we're approaching 0 from. And we note that with a little minus sign up there. Okay, so that means it's coming from the left. Okay, so it's a superscript. It's up in the top, and it says we're approaching 0 from the left. Well, in that case then, f of x is going toward infinity, or negative infinity. But if x is approaching 0 from the right, okay, so now we're approaching 0 from this direction, then my graph is going up toward positive infinity. And so we would say f of x is approaching infinity. Okay? Now, what if, my graph is all kind of messed up there. Let me get another one. What if x is approaching negative infinity? So let's say x is approaching negative infinity. What is f of x doing? So I'm saying as x is going off in this direction, what are the outputs doing? Well, as it's going toward negative infinity, they're getting closer to the x-axis, or closer to 0. So it's approaching 0. Now you might be wondering, well, does it matter that it's approaching from the bottom or the top? No, we don't usually indicate that. We only indicate it when we're going along the x-axis. Okay, so from left to right, we would indicate which way we're going. Okay, And then what's happening when x is approaching infinity? Well, that means x is going this way, and so again it's approaching, f of x is approaching 0. Okay, so let's do the reciprocal squared function. So I'm just going to go down here and draw this. So here's the reciprocal squared function is going to be f of x equals 1 over x squared. And it's one of our toolkit functions, just like the reciprocal function. Well, it doesn't look just like it. And it goes something like that. So you can see where the asymptotes are. For vertical asymptotes, it means as you're approaching that vertical asymptote, as x is getting closer, then either your graph is going toward positive infinity or negative infinity. And then horizontal asymptotes, that means that your graph is approaching that line, okay? It could be at the x-axis. It could be somewhere else. Okay, so in this case, we have a vertical asymptote here at the x-axis. And we also have a horizontal asymptote. Oh, did I say x-axis? I meant y-axis. We have a horizontal asymptote at the y-axis, okay, for this graph. Now, I wanted to do another example, though, with the arrow notation. So as x is approaching 0 from the left, f of x is approaching infinity, right? So it's going up this way. As x approaches 0 from the right, f of x is approaching infinity. Okay, so that's true too. As I'm going from the right, it's also approaching infinity. It actually is never going to equal infinity. I'm sorry, it's not going to be defined when x equals 0. We're only approaching 0. We're approaching that vertical asymptote, okay? And the vertical asymptotes can shift also. Okay, so now let's do the other part where x is approaching negative infinity. So going this way, then it looks like f of x is approaching 0. And as x approaches positive infinity, so going this way, f of x is also approaching 0. So that's how you'd write the notation. We're going to see a little bit more of this in the next example.